It's my pleasure to welcome you once again to our lesson today, still on co-linearity. In our last two lessons, we've established that points are collinear if the slopes of the adjacent sides formed by these 3 points into a triangle are equal. And then we did a calculation that proved that the slopes of two of those points that form the three lines of the triangle were had equal slopes. But in our own lesson today, we want to show that these 3 points are collinear because the area of the triangle formed by the 3 points will give us zero. So let's look at it together. In our solution, we need to understand some basic facts about the word determinant. A determinant simply gives us a method of finding a value for an array of points in a rectangular coordinates. Let's say, for instance, you have points like this, like A, B, C, D. To find the determinant of these 4 points in this array, simply means we are going to multiply um, A by D minus C by B. And that will give us AB minus BC. That's what determinant is all about. So this now, if A, B, C, D were numbers, this would have given us just one value that showed that the determinants of these four numbers in this array is that value. Start. To find the area of a triangle formed by these 3 points, let's get the triangle first out. So this triangle, remember that a triangle is a geometrical shape that has 3 points and 3 angles. So we will have, let me call these the first points that have the coordinates 1, comma 4. Then we have another point with the coordinate 3, comma negative 2. Then we have another point here with the coordinate negative 3, comma 16. So we join these 3 points together, we have a triangle. So to find the area of each triangle, we have to use determinants. And the formula to find the area of the triangle, in this case, area of triangle ABC, even though we not, let me call this A and this B and this is C. Okay, will not be equal to 1 over 2. Then you have this 1, 1, 1, x sub 1, x sub 2, x sub 3, and then y subscript 1, y sub 2, and then y subscript 3. So when we pick the cofactors in these determinants and actually find a value representing this divided by 2, that will give us the area of this triangle. And if the area of this triangle is 0, means that the 3 points on the vertices of this triangle are actually coordinated. Now let's go into action. Now we are going to begin by identifying the points x of 1, x of 2, and x of 3, and put them into y. So let's look at point A. Our x of 1 will be equal to 1. Our x of 2 will be equal to 3. And our x of 3 will be equal to negative 3. Then our y sub 1 will be equal to 4. Our y sub 2 will be equal to negative 2. Then our y sub 3 will be equal to 16. So we have this list, and we can now begin to find the area. So area of triangle ABC will now be half 1, 1, 1. So we can now have 1, 3, negative 3, Then we have 4, -2, and 16. So we are set to go into that work. So we are at this time, we want to pick the elements of that determinants formed from a matrix one after the other. Now, if you pick this point, if you stand here, that means we are going to take multiply this, subtract by this. So let's see, which now give us 1 over 2, and open a big bracket. Then we have 3, um, 3 times 16 is 48. So we have 48 minus 2 times minus 3 is 6. That's minus 6. Now, let me explain something at this point. Because of the addition and subtraction of the elements of the cofactors that make this matrix, when we are moving from this point to this point, the first value here will have a coefficient of a negative sign, the second a plus sign, the second value will have opposite sign. So this will be minus, this will be plus. So the next number then will have a plus, and if you pick this one, that means you are going to take the elements here. So we are going to begin. We are going to begin from 4 times 3 minus 1 times 16. So let's see how that works. We have 4 times -3 is, we have minus 12. That is this times this, and minus 16. And then plus this time. Then we pick these points. So we are going to have 4 times 3, which is 12 this time, minus 1 times -2, which is -2. So I want us to look at that for a while, and if you can use your jotter and solve that and see what you are going to get. Okay, so we want to continue with our calculation, and I hope that whatever you've done is correct. I want to explain this again. Our calculation begins from top left to down right. So let's see, we pick this point and we're left with these 4 cofactors. Then multiply 3 times 3 by 16, that gives us 48. Then minus 2 times minus, that gives us 6. And we have 48 minus 6. Then for the second point, we have a minus 1 here. So that's why this is minus. And then since we are here, we started from 1 times 16, then minus 4 times minus 12. So we have 16 minus 12. Then we pick the third point, which is a plus. Then picking this point, we are only left with these 4 factors. So we begin from 1 times -2, that gives us -2, minus 4 times -3, that gives us -12. So we can now go on with our calculations to confirm whatever you've arrived at in your own, to see how correct you are. 48 minus 6 is 42, and then minus times minus is plus. So this will now become a plus. 16 minus 12, 16 plus 12 is 28, and then um, this is a plus, but minus 2 minus 12 is minus 14. That automatically changes this plus sign to minus 14. So let's see what we are going to get. 42 minus 28 minus 14 will give us minus 42. So we have half into 42 minus 42, that's 0. Our answer is 0, which actually proves that the 3 points shown on the board are collinear, since the area of the triangle formed by the 3 points gives us the solution, the area as 0 square units. Thank you so much for watching, and wait for more videos on this topic.